We are excited to have you all join us for this first episode in this biweekly live series in 2026. This series is where we tackle real world challenges in test automation with the folks who face them every single day. I'm your host, Jenna Beckett, and it is great to be chatting with you all today, whether you are joining us live or you're catching the replay. We hope that you get a lot of great information out of this session, and you are definitely in the right place if you are working on scaling your testing practices, but worry about maintaining trust as your practices grow. To help us in this session, we have a guest which I'll be bringing on stage very shortly. Before we do that, just a couple of housekeeping items. Whichever platform you are joining us from, please put your questions into chat in that platform. Cypress will be bringing all of these together and we will present them to our guest speaker for a Q&A session at the end. So give the questions as they come up throughout the session. We'll make sure and get to as many as we can at the end. Now, to help us understand all of the complexities of scaling motions, I mentioned we have a guest joining us today, and I am really excited about the content they have to present. So please join me in welcoming to the stage Rakesh Sukla, Director of Platform Automation at Bread Financial. Rakesh, go ahead and join me on stage.
Hey everyone, can you hear me?
Yeah, we can hear you, Rakesh. Thanks for being here.
Thank you, Jenna, and thank you, Cypress, for giving me this opportunity. Super excited about talking about a very particular topic, which is challenging and requires a lot of operational discipline. What I'm going to go ahead is I'm going to share my screen. I'll do a quick intro before we do that. First of all, again, thank you for joining the session. My name is Rakesh. I lead the platform automation team at Bread Financial. We we are a horizontal team and we kind of support every product team in their journey in test automation. My team focus is the SDLC automation, software delivery lifecycle, and all the automation that is required for that. And a big piece of that is testing. How do you scale test automation has been a big focus. So I'm very excited to share this journey with you. I'm going to go ahead, share my screen. Let me know if you can. Jenna, can you see my screen?
Yeah, everything looks good, Rakesh. Thanks.
Okay, awesome. So the topic for today is like from noise to trust. Like this is like one of the problem we all have faced when we are scaling test automation. Many times we build a test automation, but it's not very trustworthy, right? So we're going to talk about like how do you really scale your test automation at a scale while at the same time make sure that the automation that we are building is highly reliable, is highly trustworthy. Doing both are extremely important. Like it sometimes it feels like it's very easy to scale, but it's very hard to build a trust in the system in which you are scaling. So we are going to talk about like how we can do that. The first thing we the first thing we want to talk about is like let's really define how would you categorize noise in test automation, right? And one of the biggest challenge I think we all have faced is the flakiness. You know, as you're scaling your test automation, if there's a lot of flakiness, obviously that is going to create a lot of noise for your teams. That is the first thing we're going to look at is like how do you deal with flaky failures. The second one is slow feedback. I think like once you build your automation, obviously you would like to run them in CI/CD. And another challenge which comes with is a slow feedback loop. You can have great automation, but if your automation is giving you result in like couple of hours or overnight, that is not going to provide you. That is not going to build trust, and it is a kind of a noise to the team. Like no, very few teams is going to wait for like couple of hours to get results back. Again, you can have build failures, but if your build failures lack actionable insights, lack proper reporting, it is going to create a lot of noise for your teams. I'm going to, there are a couple of things here. Like the first one is the coverage blind spots. You know, one of the challenge that you would might face is that you have great automation, but your team doesn't know that, like, how much of coverage really comes out from the automation. There's a lack of understanding the coverage, and there's a blind spot here. You are rerunning your builds again and again, and also, like, with all these failures which is happening, there is an alert fatigue. So, if you encounter, I mean, I have categorized like the top ones. All these factors contributes to noise. And again, this is a kind of a punchline I wanted to say. When the build went red, the first question was not what broke. The question was, is this real? If that is a question you are asking, which means that your quality signals are not giving enough actionable feedback. That's when quality stops being a signal. So it's very important to define, like, what is a noise is. Let's go ahead and define, like, what exactly trust means at a scale. One of the thing about trust, and building this across all the different product teams, is high signal. When your builds are failing, the failure should provide you real defects. It should not create a lot of drama, like somebody's pinging on the Slack and then bunch of people are joining in, they're trying to figure it out. Your builds and the failures of those build should provide very high signal. It's one of the very important part of building a trust in your team. The second thing is fast. It's This is something I'm going to emphasize, like, throughout the whole presentation. Like, anything that you're doing has to have a very fast feedback loop. Along with providing high signal, you do want to make sure that your builds, your automation, and the entire ecosystem that you're building is giving you fast feedback. Deterministic, another very very important criteria to build trust. Your environment, your test data, your test suites, you should have a very highly deterministic environment in the kind of, when you're building a product or when you're testing. You should make sure that uh, same failures point to the same error or the same issue. It's not like every time you're running something and a new error comes in, a new failure comes in. Creating a deterministic environment is a very important part of creating trust in your ecosystem. The next few ones I'm going to quickly go over, so we talked about actionable, like failure points should always point to a clear next step. Again, a ownership is also something we're going to talk quite a bit in this meeting. um, Once something fails, every build, every test suite should have a clear ownership, and how much time they will take to fix it, and the SLA for it has to be very clearly defined and visible. Like, your automation should have a very clear indicator in terms of how much of coverage is there, how much of risk is there. It should not be just pass and fail obviously is the end goal, but when the product teams are looking into it, there are different stakeholders involved in the whole process. You want to provide like a slightly more broader perspective in terms of coverage, risk. Those things are very easily consumed by the product teams. So we defined noise. Now we have also defined the trust. I think the question is, like, how do we how do we go from noise to really building automation that is trustworthy at a scale? So scaling and trust, the way we are going to approach is that we are going to talk about the challenges that comes with scaling, and then we're going to jump into, like, what are the challenges comes in really building like trustworthy automation, and then we'll combine together and talk about how you can do both of it together at a scale. So that will be the two-part thesis of my presentation. We are going to take a deep dive into the scaling track. We're going to deep dive into the trust part, and then we're going to combine both of it and see how you can really build, how you can go from a noisy environment where things are not very trustworthy to something that is really reliable, and every product team is kind of depending on it. I would say that is also a north star for pretty much all the teams out there who are building product. If you don't have automation that can scale, it is going to significantly slow down your release process, your velocity, your productivity. So those things, you have to be very mindful of. Okay, I'm going to talk about some really good stuff here, like the scaling problems, right? As you're building your test suites from writing one test to 10 tests to 100 tests to 1,000, in Bread Financial last year, we ran close to 2 million tests. So we definitely are operating at a very high scale. What kind of scaling problems that you can encounter here? The first one is the runtime. You know, you know, when you have a build which has like 10 tests, it might finish in one digit. Let's say it's take 5 minutes. What happens when you have 100 tests? What happens when you have 1,000 tests running in the same build? You can't have like your runtime exponentially going up as you're adding test. So something a big factor and a big problem that has come to scaling is your test build runtime. Along with the runtime, infrastructure, test automation and the scaling of test automation is directly proportional to the infrastructure as well as the application architecture. These two things are very rarely talked about in the community. I have seen, like, people talk about issues in automation, but when you don't have good infrastructure, you won't be able to scale. Like, let's compare. You have one small virtual machine to run 10 tests, and now you have 1,000 tests. That 1,000 tests can't run in the same small virtual machine. You do have to scale your infrastructure as you're scaling your automation. Very, very critical. And obviously the cost part comes with it. Duplication, um, you know duplication is also a big issue, specifically if you have teams who are working in silos. At Bread Financial, we support pretty much every single team, and each team don't each team defines automation based on number of factors. And it can be possible that one team is not talking to the other team, so silos get created. So same team, different teams are writing the same test. So we need to make sure that we are able to, duplication also kind of an issue which comes in once you start scaling your test suite. Brittle end-to-end test. Again, we have a slide totally dedicated for it. We're going to talk about different strategies that you can use when you have these kind of a situation. Environment drift and the test data pain. I can talk for hours about the scaling and the issues that come from test data. And if you have multiple environments, like one environment can have some configuration and some, it can have some aspect of test data which might not align with other environment. And it happens very frequently, specifically if you don't have infrastructure as a code. Yeah. So this is again, like, I would say, a pretty big problem. It happens at scale. We talked about unclear boundaries. Again, like, if you have unclear boundaries, it will lead to duplication. Both things we have to tackle one by one. So as we go into like really tackling like how to scale our thing, what is very critical, and it is something important for all of us, it at scale, the test suite must be intentionally designed as a product, fast, stable, owned. It's the punchline as I go into the next slide. So we talked about scaling problems. Let's talk about, like, what are different strategies you can use to scale it, while keeping in mind all these different problems can come. The first one is, and I think Cypress does a really good job here, is the parallelization. As you're scaling, make sure that you're running things in parallel. If you're using different frameworks provide different mechanism for parallelization. We use Cypress Cloud, and it does an amazing job of you know distributing tests across the runners and then collecting all the results. Also, the algorithm that is being used to do the parallelization is very important. Running the longer test first as compared to the shorter test will always lead to the better build time. So parallelization is a very important technique as you're scaling. So always try to run tests in parallel as much as possible. The other one is like splitting large specs by feature path so work distributes evenly. Um, Again, like not every test case is going to run in the same time. Some tests are very complex, can take a little bit of a more time. So identifying test which takes longer time and understanding the foundational nature of it, and then trying to providing a dedicated infrastructure for it, or trying to um, redistribute them evenly is also a great strategy. Caching in containers, like one of the during the earlier days at Bread Financial, we used to use virtual machines, and then we moved to containers. Using container is something I would say is a huge game changer. There are so many different dependencies which comes as you're integrating more products, integrating more systems, and even Cypress has a lot of other dependencies. Using Docker containers provides a great way in which you can define the versions very clearly. And then containers are slightly easier to scale as well. You can use Kubernetes, and you can use different techniques to scale your containers as you're scaling your test. So that also kind of really helps in obviously, like, one part is cost. If you use virtual machines, your cost will be slightly more than using a Docker container. Containers are definitely a preferred way as you're scaling. Along with Docker containers, many of the modern CI/CD systems are coming with global caching and local caching. Right. The first step in any of your build process is actually pulling down your Docker container. Right, before you run your test, you want to pull your container down, and you have to make sure that you are not pulling the container down every single build. If something has been already, if you can cache it through your local caching mechanism, or the frequently used container can be added as in the global cache, that will also significantly help you in scaling your builds. Couple of things that we will do more deeper dive as I go into the next slide is, um, failures will always happen in your build. Running 1,000 or 2,000 tests, specifically more complex in nature. If you're using Cypress, those will be targeted for web application. A lot of the failures can come from a wide variety of sources. So what you can also do is, like, if only one test has failed in the entire build, or like 5% or 2% have tests have failed, you can have a smarter retry policy within the build. You only can rerun the failed ones, while don't not focusing on the ones which has already passed. So smarter retry policies, we're going to talk about in the next slide, definitely helps. um, as you're configuring your build in the CI/CD, there are a lot of days in which you can do resource optimization. You can target a more complex build for a higher machine, and provide more compute in terms of CPU and RAM. And like builds which are simple, does not take too much time or too much compute, you can also allocate resources separately. So how you're going to do your resource tuning is something very contextual, and you have to figure out like what is the right size for running the build. What at Bread Financial, what we have done, we have defined an SLA for each build, and our SLA is any build, does not really matter whether it is 1,000 tests or like 10,000 tests, you should always run in 10 minutes. So anytime we cross the threshold of 10 minutes, we start talking about like what kind of strategies to use to again reduce the time. We can do divide and conquer, we can throw more infrastructure, we can move some complex tests to some other other builds. So there are a lot of different ways in which you have to do the resource planning. But one thing which really helps is have some kind of an SLA defined for your builds. Do not let your builds run more than 10 minutes. 10 minutes should be the absolute target if you want faster feedback. The last one is selection signals. Actually, let's that is something we're going to talk more in the next slide. Couple of things to avoid is like unlimited retry. Cypress obviously has an inbuilt retry option. You can configure your particular test script to do retry multiple times. Also at a CI/CD level, they also provide a lot of retry option. You obviously want to retry, but don't retry unlimited number of times. That is not going to provide you very actionable feedback. The other thing that to avoid, and we kind of try to stop doing, is no need to run like massive test suite in every single PR. Obviously, for release and everything, you do want to make sure that you're running all the tests, but there is an intelligent way of do it, which we're going to talk about in the next slide. But in general, try to avoid like running this massive test suite every single PR. Couple of techniques we talked about to get faster feedback. We're going to talk about selection and prioritization, and this is where I feel like LLMs and the world of AI are really going to shine. And we have experimented in Bread Financial many of these features. We are building all these features from ground up and taking advantage of LLM to do a good chunk of it. One of the selection signals is tagging strategy, right? Once you're writing test script, uh, you can tag your script by a lot of different attributes. Like, is it a critical test suite? Is it a smoke? Is it a regression? um, Tagging really helps when you have to filter out bunch of really critical tests out of the whole test suite. You can also tag for accountability and routing. That is something is also going to be very useful. um, I'm going to throw it out there, and this is something teams to explore, is the tagging. If you can define a good taxonomy for each of your product, and define that taxonomy in your framework, LLM is really useful to provide the tagging recommendation. You can let your LLM to look at your taxonomy, how you want to structure your tags and what kind of tags is possible. And what we have seen in general, like LLM does a really good job to provide you a very consistent tagging across all the test suite, and then you can take advantage of it in terms of filtration, in terms of your execution strategy. The I would say is kind of a subset of tagging. In all of our, uh, there are always a couple of applications which are more critical than the other applications. Applications like login functionality, authentication, for us, the checkout, specifically the ones which are user facing, those are very critical application. You can also tag them appropriately. And once you see somebody has made a big change in authentication, you obviously would like to run a larger test suite as compared to a more targeted selection. So risk-based selection is also a great way to think about it, and there are multiple ways you can approach it. Tagging is obviously one way. You can also categorize. You can also have different builds for those particular application, and then you can specifically run that. Change impact signals. This is like one of the pretty complex problem in distributed system. Is like when you make a application code change or when you make a pull request, how do you take the context of all of that and filter it out and figure out which particular test suite would be corresponding to those particular code change? But now with LLM and AI, this problem you can solve to a greater level. And this is another way in which you can integrate a selection mechanism in which somebody has made an application PR and there are a bunch of files which is changed. your system can understand the changes and then just run the test suite that will give you, that is very much uh, specific to the change which has been made, and give you the faster feedback. So some of the great ways in which you can implement the strategy, and these things are very important at a scale. At a scale, you just cannot run every test every single time. The infrastructure, the process of debugging, all of that will be very, very higher. uh, so we talked about, like, how it runs in PR, like all these things. You when a PR comes in, you can have a decision engine, and based on that, you can target it. You can also divide your test suite into something which is very fast tier, or something which is deep tier. Fast tier will very quickly run and give you the feedback. The deep tier will take a little bit of a more time to give you the content, to give you the feedback back, but it's not blocking in any way. So those things are also pretty useful. I can i can take some questions, Jenna. What do you think? So
Yeah, absolutely. I had a couple that came up, so I will pass them over to you. We can do a little discussion and then head back to kind of wrap up presentation. Starting with containerization, you mentioned that this was critical for scaling testing practices and being able to achieve fast feedback without a lot of infra overhead. I would love to hear about how your team keeps your containers up to date. Do you have a dedicated pipeline for that, a process defined for making sure those containers are up to date at the time they're needed for test runs?
absolutely. So we have a separate repo specifically defining the changes in the Cypress Docker container. So anytime there is a change in the Cypress version or the underlying infrastructure, we make all those changes in the GitHub and then push it to our ECR, and a new Docker image gets created. We tag our Docker images appropriately by versions, and generally we use the latest image. But many times, because of some bug or anything, we can always go back to the previous version. So versioning is very important. Um, we we also have pipelines that runs the latest versus the previous version, specifically to know if there is a bigger change happened in Cypress, it's not breaking our existing test. So um, and along with I talked about Cypress. Obviously, they have a great release process, but our framework is dependent on many other applications, and they have their own versions and all of that. So those are also defined within our GitHub repo, that we pretty much every day we make sure that we maintain it and we update it as required.
Awesome. Thanks for sharing that. Another thing that seemed really integral to the process that you're proposing is selective testing. And one thing you mentioned was, there are a lot of different taxonomies you can use for tagging your tests in your test suite. So I'd love to hear about the strategy your team takes. Do you do feature based? Do you go off of like smoke, critical path, regression? Like what has worked for you all?
Sure. So the taxonomy that we have defined here is in two ways. One is a global tags, and global tags is something which is very consistent across all the framework. Inside global tag, you have, like, the type of test. Is it a smoke test? Is it a regression test? Is it a critical test? Things like that. And that will be very consistent across all the framework. um, we also have the priority, like is it a very high, medium, low kind of a priority in the global tags. And we also have the layer of test. Is your test is specific for API, UI, database, or a combination of API and UI? Those kind of a signals which are very broadly applicable across all the framework, those things we have defined at a global level, and we call it a global tag. Then for each product we define feature tags. In terms of nesting, we do not have multiple nesting in the feature tag. we define the very top level feature that is applicable for the product. And when somebody makes a PR change, we look at the global list of tags, we look at the feature tag, and we say what will be the most applicable for this particular change. And we also have pretty tight constraint for our LLM, and also have defined very fixed path. Like, there is a particular structure in which we want the LLM to respond, and LLM again responds it back. Now, those things are tied up with our Git workflow. So when you make a PR, we also make an additional PR like, hey, these are the best recommended tags for you. If you feel these are good, accept it, and the commit will be added on the top of your Git. If not, you can make changes on your own. So there is always human in the loop in terms of how we have defined here.
Awesome. Thank you for sharing that. We, in talking about taxonomy, we said that you could go with smoke, critical path. The thing about smoke test is I feel like every person that I talk to defines that differently. So I'd love to hear about your definition of a smoke test. How is that term applied at Bread Financial? Maybe some things that have worked, maybe some things that haven't worked that you've learned along the way, but tell us about your definition of smoke test.
Sure. The way I think about, first of all, it's a pretty valid problem. Even I struggle, smoke, regression, sanity, and there are a bunch of terms to do it. Um, at Bread Financial, I would say smoke is a subset of highly important test of regression. Regression is something that you have to run for every release, and every regression test has to pass. But many times what happens is like we made a change, and a client got impacted and things like that. And if your regression test is not passing you feedback very quickly, the other way to think about is like, instead of running the full suite of regression tests, can we run some smoke test, something which is the most commonly used things a client will use in production. I would say that's how we define it. Like, specifically when I use the word smoke, I'm directly referring to something that I can quickly run in production.
Mhm.
So yeah, that's how we think about tagging smoke test.
And one thing that you mentioned that your team utilizes the Cypress Cloud for, some of your workflows and for, test quality signals. Um, I often talk to folks about when they're talking about scaling their testing practices. The question comes up of how do I organize my Cypress Cloud instance to maximize my scalability, maximize the features that are available out there. So I'd love your perspective on that. Like, how does your team organize, let's say, your Cypress Cloud projects? What's the deciding factor that says, this is one project versus a separate project in the cloud?
Sure, it's a great question. And if I have to go back like 5, 6 years ago when I really started all of this, the way I would organize projects in the Cypress Cloud is, any team or any application which cares about the metrics around their test automation, it can be directly aligned with an application, it can directly aligned with a product. It's all about the signals, right? I mean, if a product is specifically interested to know the coverage, specifically interested to know how much of flakiness it is, how much of test size it is, I would create a separate project for that. That allows you to get a lot of really great analytics across the board, as compared to having one huge project and there are like 10 new project inside it. That is going to create a lot of noise, and you won't be able to get very actionable feedback for a particular product. There is more to say here, Jenna, but I would say, like, if I have to go back, this is like one thing I would really fix, like aligning the project on Cypress dashboard to something product, something which so we can get like proper analytics for each application or product.
Yeah, so you're really talking about like thinking about the end state here. Like, what information do I want to see? Do I need to have at my fingertips, and designing your structure off of that desired end state? I really like that perspective of thinking about what the outcome needs to be to decide like what the actual implementation looks like.
Yep. And specifically, the reason I mentioned, because we are a horizontal team, and we support every product team, and each product team should have metrics so that we get a sense of the maturity, what is the progress, and stuff like that, so we can centrally look at all the products and the and the progress that has been made. So yeah, I mean, again, that's like one way of thinking about it. Look at your org structure, look at what kind of things you want to derive from it, and based on that, structure your dashboard based on that.
Excellent. Those were the questions I had on hand. I could turn it back over to you to wrap up presentation, and then we could come back and do another Q&A cycle at the end.
Okay, awesome. So we started with noise. We defined what trust looks like. We talked about the challenges in scaling. We talked about different ways in which you can find solution to your scaling problems. Now we want to jump into trust, right? Let's assume we have scaled our automation. Now the next challenge which comes in is like, how do you define trust? I mean, you can obviously scale, and you have a great infrastructure to run like millions of tests. What happens if the tests are failing? What happens if there are unclear boundaries defined? What happens when there are a lot of flaky flavors? That effort won't be usable, right? That So along with scaling, this is also a very critical part. Like, everything has to be very reliable. So there are a couple of things to think about as you're scaling, is like, what are the different trust killers in your journey and how you can eliminate that. And there are a couple of that I have identified here, and how we can resolve it. One is timing and weights, right? You are testing an application, and your application is not in sync with your framework, or with your automation, whatever framework you guys are using. That is going to cause a lot of failures. The thing is also to think about is test data. What are the different ways in which you are scaling your test data, making sure that test data is very unique for each test suite. You're also isolating your script with the test data. How you're handling the environment drift. In most enterprises, we always have like multiple environments, and code is always flowing from dev to environment 1, 2, 3 before reaching production. What kind of strategies you're using so that the environment drift in terms of configuration, the version of your services, the all of that things are in sync, so you're always getting reliable results from your test suite. And there are a few more, like shared state, async UI. I would say this is like another area where Cypress does a really good job, because of its inherent architecture. um, when you have synchronous call or asynchronous call in your application, how do you make sure that your framework kind of understands that, and wait for those asynchronous calls to complete before moving to the next step? So these are obviously not the full list, but a great list of failures that can be a huge trust killers. And as you're scaling, you also have to solve problems of the all of these issues as well. Couple of ways in which you can approach and try to solve it. Isolate. I think I can't emphasize enough like how critical it is that when you are writing your test scripts are independent, are isolated. We talked about parallelization. Parallelization is not going to work if the isolation does not exist in your test suite. Every test script that you have, you should be able to independently run them in parallel. So it's a big part of really scaling it. Waiting on the right thing. If sometimes you encounter flakiness because of some you know not waiting on the right thing, I always feel like just having a discussion with the application developer and understanding the application architecture is also very important. You don't want to write your test scripts without understanding all of that. So if you are ever in a stage where you know you are not waiting on the right element to render, have a discussion with the application developer, or have a discussion with the architecture, like why it is happening and what is the best ways to to fix it. Like, Cypress has this Cypress CY intercept, which I think is great. in which you can wait for a network call to finish, and there are other ways to wait on the right thing. But there are different techniques also to do this. Stabilized data, I'm not going to go too much into it, but test data is a whole different topic. But like, you should, as you're scaling your entire ecosystem, how you generate your test data is also equally important. This is actually a really important one. Mock boundaries when appropriate. When you're running your test suite, it's a best practice that you should always mock the third party systems. The reason is because you do not have, um, third party systems can go down anytime, and they can also fail in a very undeterministic manner. So the more third party or the more systems you will integrate in your test suite in which you do not have direct control, it is going to add like all sorts of flakiness and undeterministic environment for you. So try to mock the boundaries whenever it is appropriate, and that is something I would say definitely an important pattern. Locking the environment, I can understand it's not always easy, but once you're ready for the release, having a fixed version of services and fixed version of application configuration locked in an environment will provide you a great results from your test suite. You don't want your environment to be keep changing, right? At one point you do have to lock it so that now you can do a proper testing before going for production. So see opportunities in which you can actually lock down an environment. So as we are scaling, these things are also important. We want to build trust at scale, right? Another important part, this one I would say is, uh, specifically in terms of how you define your quality gates. Once you have the automation, obviously you do want to make sure that the automation is a part of your SDLC journey. But the best way I feel to approach it here is like having a blocking gates, but also being pragmatic about things which can fail and things which can take a lot of time. The best way here is that you can divide your blocking gates into smoke critical end-to-end test. These builds should not be a huge one. These builds should be something which you maintain consistently. You have high reliability, of the build, and this has to pass as a part of your build process. And you have a very strong, very good SLA to make sure that if something fails, it leads to a some level of a issue in your application. Then you can have another build which takes a little bit of a longer time in a non-blocking way. So these are your hard gates, something that has to pass, and these are your soft gates, which obviously you want them to run, but it is in a non-blocking way. And the way to approach it here is like, if you're starting this journey from the very beginning, don't be very strict about it, at day one. Try to integrate in a small increment, build trust with your team, and eventually, if everything goes well and you have a lot of data over a period of time that all my builds are great, you can have a conversation with the team and you can integrate all of these build as a part of your release process. So think about blocking, think about non-blocking, think about incrementally scaling, not like adding everything together and then causing a lot of chaos and noise. You don't want that. You want to build trust day by day, and once the trust is built, you can run even longer test. I mean, those things you can also work it out. There's a lot to speak on this topic, but I've covered like very high level, like how you can think about it. Ultimately, as an engineer, what you want to make sure that the experience has to be fast, transparent, and consistent. If these things are not getting met, then it's time to fix those issues, then come back to the CI/CD process and integrate the builds. Also very important for building trust, right? Um, this is going to be my last slide. We talked about scaling and we talked about different strategies that you can use to build trust. How to actually make it happen? Like, what is the operational playbook here? Couple of things I want to call out is an ownership. Every test suite should have an ownership and should have a path to escalate whenever required. So as you're building, your great automation, make sure that all the other teams which are kind of depending on it, they should have an easier way to escalate and reach out to the owner if something is not working out. SLAs for your failures. This is a pretty important one. As I mentioned, at Bread Financial, we have an SLA of 10 minutes. We want to make sure that builds finish within that particular period of time. If not, let's come back and do our homework and figure out what are different strategies we can use. Have a very good SLA for, if something is not working out, how to fix it. Fix, you know, I would say, like, at Bread Financial, we try to fix it everything as soon as possible. The best practice is try to fix it in one day. So the next day, it's a if something is happening, you figure it out, like, why that is happening. So try to fix and triage in a day. Flaky budget, again, similar to SLA, also have a very strict flaky percentage for your test suite. And this is where I would also call out Cypress dashboard. If you create a project on the dashboard, it will automatically provides you all those great insights. Don't have more than 5%. I think 1% is a bit ambitious, and depending on enterprise to enterprise, if you um, anything between 1 to 5%, I think is okay. Don't go beyond 5%. Have a strict a track record for your test suite, and make sure that the flakiness is not much. If you encountered flakiness, and that can again happen for a variety of reasons, have a quarantine process for it. Figure it out how to isolate those test cases in your flow, and make sure that you have a particular owner and ticket required to fix it ASAP. The last one is a dashboard. um, I think Cypress dashboard is great, but if you use any other framework, there are a lot of different techniques to make sure that you're getting all the good analytics for all your build. So have dashboards for it. I mean, treat your test suite, as I mentioned, like a product, right? It has to be fast, it has to be stable, and you should have all the metrics to track it. So define all of that, capture it in a dashboard, and review it pretty much every day, and that will really go a long way. As you're scaling, you will build trust. That's that's very pretty important.
Rakesh, I have a question for you directly about the comment you just made of your test suite being a product. That's something that, a lot of people talk about, but what implications does that have? Saying that I treat my test suite as a product, what implications are there that makes that different? Does it impact like prioritization of issues that are arising? Is the primary impact ownership? Like what insight can you give me around that?
The implication around, like, again, like having a test suite which is taken very very seriously as a product in production will lead to all sorts of benefits, right? The biggest one is, like, your release velocity. You might be releasing once or twice in a week, but if you have a way in which you can get a faster feedback, nobody can really stop you outside of the compliance and other thing. But in small companies and medium sized companies, you know like, you can deploy pretty much every day. If you treat it like a product, and you have all the great analytics around, like, what is the coverage I have, how much of test script I have, what is the correlation, what is the flakiness. If you know that is like one of the thing. The other thing is also comes back to productivity, and that's where I feel like, taking your test suite seriously ultimately leads to a much greater engineering productivity, specifically when you're locally developing a product. And once you finished, let's say, a partial part of the product, and you want some level of a feedback, and your test suite can provide you that feedback very quickly, it becomes integrating smaller pieces even more easier, and that ultimately drives the productivity of the whole team. So that's the implication. I mean, there is good things, but if you are building test suite, and it's one of the very critical part of the software development lifecycle. Pretty much all the decisions in your whole flow is taken by how good your test suite is, right? And so, yeah, take it very seriously. Think like a product. Think like what all different metrics I need to have to capture the how healthy things are, and that will ultimately leads to all the great things.
One thing that I think of when I hear people talk about test suites as a product is the alignment required around standards. So when I think of a product, I think of those engineering standard playbooks that you operate off of when you are writing code for a given application or service. So to me, that says that your team at Bread Financial has done a lot of work to align on quality standards. What mechanisms do you all utilize to create that alignment given your distributed team structure? Is it communities of practice? Do you have like defined forums? Like, what do you all use?
I would say, like, since we're a horizontal team, and we do take a look at framework across the board. There is The first part is the code review process. There is somebody from the platform team involved in the code review process, and the platform teams are trained. They get proper training. What kind of standards we have, what kind of linting mechanism we have, what is an anti pattern, things like that, which we very often discuss. So they do understand all of that in the code review process. So that's like one thing. The other thing is, like, we do office hours twice in a week,
Mm.
and we invite pretty much all the product teams, and anybody can come ask questions, challenge the team. So that is another great way in which they interact with us. We also have the platform team directly embedded in many of the product teams. So that is like another way in which the product teams is constantly in touch with the platform team. So this platform team is not like we're just building technology and giving it to them. We work very closely with all the product teams, you know implement those technologies, provide the best practices, and then continuously monitor and review their work as well. So in nutshell, that's how we do it. But again, there's more here.
Yeah, I think that, all of that leads me to believe that there is a shared sense of quality ownership within your organization. That code review process, those office hours, and being able to discuss in open forums the standards that you're applying to your quality practices. That I think is probably a very important piece of your one track in your process of scaling trust is developing that kind of shared quality ownership through a sense of stakeholderness in the quality process, whether that be direct involvement with test authoring or in talking about standards. Those things seem to connect. A question came in from the audience on one thing that you mentioned, and as far as a tactic here in quarantining test. And the exact question is, how does your team handle quarantine of Cypress tests for future runs? Are you tagging them? What method are you using to identify a given test as having been quarantined?
In terms of quarantine, we try to not skip test as much as possible, but there are situations in which, because of some conflict, because of different versions, because of this and that, we do have to skip the test. So there is a way. So Cypress inbuilt automatically provides a way in which you can skip a particular test case. That is like one way of looking at it. The other way is like this kind of a mechanism you can also build inside your CI/CD. Given a particular pattern, you can define a pattern for tagging, or there are other ways to approach it. And then if you find this particular pattern in a test suite, skip it. So there are different ways of approaching here. These are the two very commonly things we use.
Excellent. Another thing you mentioned here for your run book ingredients is a flake budget. First of all, I love the term flake budget. Like, I love thinking about I have X number of flakes to utilize in a given period of time. But my question kind of is involved how you apply flake budget. So you had mentioned the ideal of 1 to 5% being the maximum amount of flake you would want to see. But how does that apply over runs? Are we talking about on a per run basis? Does your flake budget apply in a sprint or a given set of time? How do you guys use that at Bread Financial?
So when I talk about flake budget, what I wanted to make sure is like you define a threshold of flakiness which is accepted to you. Generally, I think it's a good idea to not have more than 1 to 5%. And more than 5% leads me to believe there are other factors. Either you're not thinking about it or it's totally out of your control. So in that kind of a scenario, it will be really hard to, scale your test suite. So the way we approach it here is that again we are very disciplined about our build process, and I mentioned that we try to make sure that our builds are you know less than 10 minutes as much as possible. There are some exceptions though. As a part of it, we also look at how healthy the test suite is, and what are the flaky tests which keep coming again and again. So you know we look at this sort of a data pretty much on a daily basis, and depending on where the test script is coming from, we ask the engineers to fix it, and try to make sure that the flakiness is less than 5% across your build. So it's a daily discussion, I would say, and identifying the issues and keep talking about it and making sure that engineers take full accountability for it. I would say that's how we approach it here.
Well, we have reached the end of our time for the Bug Bash, and I want to go ahead and say thank you so much, Rakesh, for walking us through this presentation. I think you've given us all a lot to think about in terms of how we scale and what are the considerations, the complexities that are involved in that process, and how important it is to not think about this just in terms of the infrastructure or the test suite, but the sentiment and the team beliefs and shared sense of quality, understanding that and scaling that in parallel is going to be what makes for a successful outcome. So thank you so much for joining and sharing your expertise. We really appreciate you being here at the Bug Bash.
Yeah, thank you for the opportunity. And if I'm not answered any questions, reach out to me on LinkedIn, or maybe I think LinkedIn. Just reach me out there, and I'll answer those questions as well.
Thanks, Rakesh. All right, for everyone joining us, we appreciate your time. Thanks for joining this session of the Bug Bash. Join us again. We are a bi-weekly live series, so we won't be here next Tuesday, but the next one we'll be back. Joining us will be another guest, and we will be talking about some implications of AI in testing. So appreciate your time here today, and we look forward to seeing you at the next Bug Bash. In between now and then, happy testing, everyone, and we will see you again soon.